Welcome back, dude bros. My name is Chili and this is lesson 4 of the advanced programming tutorial series. And I'm coming at you from my newly upgraded kick-ass computer. And it's kind of fucking around with me because I had all my tablet settings and program settings all set up the way I like for recording, and all that shit went out the fucking window. So now everything is all janky and fucked up. This is my third attempt at recording this video, but we're gonna soldier on and see if I can't get this shit to work. So today our ostensive topic here is gonna be line clipping, but in actuality we're just gonna do a bunch of random bullshit, because line clipping ain't gonna take that long. You'll see when we get there. So yeah, yay for random bullshit. First things first, I gotta explain something. I got a little explaining to do. Lucy! Now the thing is that I have never actually kind of outlined what this game is going to be all about. I gave you a vague idea of the type of engine we're going to use. I showed you that example of the Genesis game, what was it called? Terrarium or something? I don't know. Subterranea, I think it was. But that's all. And I want to go over right now, just in my head, what I imagine this game to be like. So the basic premise is you're a ship, you fly around, you're using rather semi-accurate Newtonian physics. So you've got thrust, and that will accelerate you in a direction. If you want to change direction, you've got to decelerate and accelerate in the new one. It's pretty hard to control a ship like that. If you've ever played Kerbal Space Program, you'll know it's not easy. And that'll be part of the challenge. And the object will be just to get to the finish line. So it's just a time trial game here. But there will be a few quirks to it. Interesting little features. Now the first thing is your ship is going to have a shield. And that will allow you to ricochet off the walls, if you so desire. However, you'll take damage on your shield when you do that. Now the idea is that, for example, taking turns like this, you'd have to take them quite slowly in order to make it around here without hitting the walls. So what you can do is you can go full speed and just, like, for example, here or here, you could just go full speed here and then bang off this wall and zoom down here, instead of having to like slow down and then kind of like correct your course. So that the player will be given choices whether or not you ricochet off the wall or whether you take the turn, because every time you ricochet you're going to lose shield energy, so you can't just do that for every single turn, otherwise you're going to run out of shield and you're going to explode. So that's one little aspect of the game. I mean, the difficulty of control, the realism of the physics, and the ricocheting, the shield. And then you could also like add other things, like for example, maybe here, see if I can't get a good color there. Maybe here you've got like a black hole, right? So what you can do is you can use that to slingshot. If you go just the right distance from the black hole, it will slingshot you into your target. Whereas if you're a little too far away, you're going to miss your target. And if you're a little too close, you're going to hit the black hole and, you know, get sucked in and die. So that's another little environmental hazard you could add in there. And there are other things. You could have like a tractor beam, you could have weapons, you could have enemies and other obstacles. So there's lots of shit you could do with a game like this. So that's the basic idea of what we're going to be doing for this game. Now, line clipping. So while going back to our diagram here, let me just get a color. This one. This is obviously going to be bigger than just a single screen. We're not going to do this whole thing on one screen. So you've got your screen, and you're going to have wall lines and shit running off the screen. So you're going to need to be able to clip that shit. Eventually, we're going to get in there with our viewport and camera system that we use in the platformer. But not right now. First, we'll just handle clipping. So how do you clip a line? If you've got your viewport here, and we're going to draw a nice big yellow line across. That's not right. Yellow line. There we go. So you've got your lines, got start point, end point. It's running off the screen. If you try to draw this bullshit, you are going to get errors or failed assertions or whatever. It's not going to be pretty. So what you want to do is you want to find a way to only draw the pixels that will actually appear on the screen. Now I hear some of you out there already saying, Chili, I got this, man. You don't even have to go any farther. All we got to do, listen up. Oh wait. Oh yeah, I wanted to show you, okay, scratch that last thing I just said. I wanted to show you what I was imagining for the game. This is the prototype that I work on when I'm trying to figure out where we're going to go next. I have ideas, I try them out before I actually put them in the tutorials. Yeah, there's actually a little planning that goes into this shit. You might be surprised. So here's the idea, at least where I'm going right now. There's going to be more, but the basic idea of the physics. Now I'm going way too fast. See, it gets hard when you go fast. But that's just like real physics. No. Now it's just fucking pinball because I can't decelerate. What I gotta do is I gotta wait until I'm going in the right direction. That's wrong. There we go. Okay, now I got my speed down. Now I can get it down a little bit more. There we go. Yeah, so this is where we're going to be heading in the next few lessons. And that'll teach us a lot of interesting techniques, a lot of stuff that will be useful when we move into 3D. But there's the basic idea of what we're going for. Now, fuck that bullshit. Line clipping. So I ask you the question, how do we clip this motherfucking line? And you say, no problem. I can do that shit in my sleep. Let me show you. We go to the framework. We go here to D3D graphics. We find, fuck that. We find our draw line and we go down to where the pixels are and we say if x is greater than 0 and x is less than screen width minus 1 and blah blah blah. No. Stop right there, sir. You have said too much. This is not the way a civilized person does clipping. If this is your idea of clipping a line, then you might be a savage. Now let me show you how a real person, a real man or woman, will clip their lines after I drink water. Now how you're going to do this, I mean, clipping lines by checking every single pixel to see whether it's in the screen is super inefficient and dumb. That, my friends, is the naive solution. What you want to do is you want to modify your geometry. You want to take this line and turn it into another different line which has the same image on the screen but which does not extend beyond the screen. So you want to move your endpoints along the line until they fall within the viewport. Now, how are you going to do this? Well, it's a simple math problem. Anyone who's taken, grade 10 math should be able to handle this one. It's intersection between two lines, right? So you find the point of intersection between the line corresponding to the top of your screen and the line you're trying to draw. And that point here is going to be your top point, and you do the same for the bottom, you get your bottom point. Not very difficult from a mathematical point of view. However, the problem is that you've got a lot of cases. Your lines aren't always going to go from top to bottom. Sometimes they're going to be going from here to here. Or sometimes they're going to be going from here to here. Sometimes they're going to start in the center of the screen and then go off it somehow. And yeah, I might go from bottom left to top. And there's a bunch of different cases, and for each of these cases you're going to have different lines to collide with. Sometimes you're not going to be on the screen at all, and it's going to be hard to figure out what calculations you need to make to find the endpoints, or whether or not the lines are even in the screen altogether. Because you don't have this information like we can just look at the image and say, yeah, that's on the screen, that's colliding with the top and the right. You only have the start point and the end point, and you've got to figure it out somehow, algorithmically, mathematically. It's hard, people. So what you could do is you could get out your pen and paper, you could do your figuring, think of all your different cases, work out your algorithm, code it up, debug it, incorporate it, debug it again, and maybe have something in the end that works pretty decently. But that, my friends, is the retarded way to do things. Now let me show you the smart, lazy way to do things. What you're going to do is you're going to go to Google and you're going to type in line clipping algorithm and look at some web pages. Check this shit out, because whenever you have a problem like this, the first thing you should ask yourself is this a common problem? Is this a very specific thing, or is it a general problem that people have likely solved in the past? Because if it is, and then you're going to try to, roll your own algorithm, you're just wasting your time. So find something that works. Now, you can find an algorithm online and then figure out how to implement it in your own code, but the best thing to do is to find code and just copy and paste it, or find a library and use that library, like we did with the DXF loader. So it just so happens that Wikipedia here has an algorithm for us, and they have the C++ right here. So we're just going to copy and paste this bullshit into our program, and that is going to be that's going to work. You know why it's going to work? Because Chili said so, that's why. So we got our code here. Now the only thing is that it's not our code, someone else's code. So we got to kind of massage it and make it fit in with our framework. Now you can read up on this function. When I first did this, when I was working on the prototype, I read up on it a little bit. I sort of tried to figure out how it worked, and I had a very good idea. Not 100%, I couldn't code it all from scratch, but I had a decent idea of how all the parts fit together. But I'm not going to go over that in this video because it's not important. If you want to figure it out, you can do that. You can read up on the Cowan Sutherland algorithm and understand why it works. The general thing is, it characterizes the start and end points of a line as either falling inside the viewport or in some region around the viewport. It divides the regions around the viewport into 8 sections. And depending on the characterization of the start and end points, the behavior of the algorithm will change. And it iteratively calculates, intersects, and revises the endpoints until either the line is completely in the viewport or completely out, in which case it either draws it or rejects it. That is the basics of the algorithm. Now this function here computes which region an endpoint is in. You get an X and a Y for the point, and it will give you the region in which that point lies relative to the viewport. And then here is the actual clipping algorithm, which calls this function. And here we have some values for, what do you call it? For these regions. They all have their own codes. And they're encoded with these numbers here. It's binary encoding. One hot binary encoding if you want to be specific. But none of that shit, none of that implementation details, none of them are important. What is important is getting this code to work within the framework of our program. So first thing first, let's look for underlined squigglies and fix that shit. Okay, xmin, xmax, ymin, ymax. Those are obviously the extents of our window here. So what we're going to do, ladies and gentlemen, is we're going to define those up here. Later on, we are going to we're going to have our camera and viewport system. And when that day comes, we won't need these xmin, xmax. That we'll just use the stuff from our viewport. But for now, screen. Why don't I have screen width? Oh, right, because I'm not a member of. Okay, whatever. We'll just do D3D graphics screen width -1, and we will put that in parentheses. Okay, and we'll copy and paste this. Y-Man, X-Man, my favorite comic book series, the X-Man. I'm just joking, I have no idea. I have no idea about that bullshit. Hey, height. Alright. Okay, so that fixes this bullshit. Now we also want to change all of our doubles to floats, because doubles are for... not for us. Too rich for our blood. We'll take our floats, thank you very much. Might as well do that here as well. And also we have xmax and ymax and all that crazy bullshit down here. So let's copy and paste our definitions into this one as well. And here we have if except, meaning if the line is within the boundaries of the screen, we want to draw. So we need our own drawing function in here. That's going to be, what is it going to be? Draw line. X0, Y0, X1, Y1. See, I want to change these into vectors, but if I do that, I need to figure out. Let's look at what we had before. I shouldn't have deleted that. I should have looked at it. So the output value is going to be X0, X1, Y1, Y1. Okay, first thing we're going to do here, get rid of these X0s and whatever. Vec2 P0 Vec2 P1. So we've got our 2 points. Now we've got to do a little find and replace. So we go into here. We want to replace X0 with P0.x. Replace, actually, we want to limit our activities to within this area here. Replace all. 14 occurrences replaced. Now we want to replace x1 with p1.x. 8 occurrences replaced. Very nice. Now y1 with p1.y, 8, and y0 with p0.y. And there we go. Now we have vectorized our algorithm here, sort of vectorized it. So here we do draw line x1, y1. So that would be p0.x, p0. Actually, we want to convert this to integers. p0.x plus 0, not times, plus 0.5. This will round to the nearest pixel. And p0.y, p1.x, p1.y. Now we do our copy pastas, our creepy pastas, and other side. Good, good, and good. There. How's that? Not good enough. We need, first of all, we need a color here. D3D color. I'll go down here. Color. How's that? Draw line is on it. Ah, okay. That's fine. I know what the problem is there. So now what we got to do is we've got, well, let's change the name of this. Draw line clip. And now we creepypasta. We go to our header file and we add a new function declaration here. We go back. We go down here. Copy D3D graphics. Scope. Resolution operator. And now we are part of D3D graphics. And now this should work. Draw line is undefined. Error identifier. Draw line is undefined. Maybe it's just... There we go. Just fucking with me again. As usual, my IntelliSense is fucking with me because it can. So this should work. Let's build. Ah, because we copy and pasted from a web page, some of the encoding shit was all messed up. That's fine. Alright, so let's go to game. No, first let's go to polyclosed. Go to our draw function here, and we want to draw line clip. Clip. There we go. And what else? Let's go into game. Minimize our framework bullshit. We'll go into game here, and we will here we'll go float mouse.getMouseX and float mouse.getMouseY. Build it and run it. And now, my friends, our spinning dick can fly off the screen, no problems. Lovely. Look at that beautiful rotating phallus. It's so good. But we still have work to do, my friends. We're only 20 minutes into this video. Can't end a chili video at 25 minutes. That would be a travesty. So, first things first. Having code that works is fine and all that, but I like having code that is sexy. How can I sexify this code? Well, looking at our drawline clip, we notice something. We notice that compute out code is only used, it's a function, it's only used in this other function. It's never used anywhere else. It is specific to the clipping function. Now, the reason why we make it... Oh, yes, sirens. Yes, I hear you. Very good. Oh, shit. This has got to be a float. Fuck that up. But that's okay. What else? What was I saying? Oh, yeah. So, the compute out code only used in here. Now, it's used in a bunch of different places, so it's a good idea to make it a function, because then we don't have to, repeat the code here, and then down here and down here. So making a function, good idea. But if it's only going to be used inside this other function, it's kind of a waste to have its own separate external function. Now, up until C++11, you had no choice. You had to make another function. I didn't even make it part of the D3D graphics class, so it's not in the header file. No other translation unit can see this function, but it's still out there in the world. Now, how can we make it more compartmentalized, more encapsulated in this other function? Well, that, my friends, is the purview of the Lambda function, which is a new feature of C++11. And I'm going to show it to you guys right now. So what we do... Now, first of all, a Lambda function is a function that you can define inside another function. You define a Lambda function and it acts like a function pointer. And you can then call that function. Now, there's a bunch of ways you can use Lambda function. You can use them to spawn threads. Instead of writing a separate thread function, you can just spawn the thread with a Lambda. Or you can use them with STL algorithms. But I'm not going to go over that shit. That will be for another day if we come to it. And those are definitely useful things, but only if the opportunity arises will I treat them. And it may very well, but today we don't have that. So today all we want to do is use, we want to define this function inside of another function and use it there. So what we're going to do, my friends, is we're going to, first of all, we're going to go up here. And we are going to include functional, yes. This is a C++ include, you can tell because it doesn't have the .h at the end. And this will let us have the function object. So std function, now we need the type of the function. Our function is going to return out code. And it is going to do what here? It's going to take as parameters float x, float y. So here is the definition of our function there. Returns out code, takes x and y. And we'll call our function compute outcode, because then we don't have to do any copy pastas. And now we have to assign a function pointer to our function object. So there, now we define our lambda, and we do it like this. Square braces, curly braces, function body. Now the curly braces are going to be, we can just do this. Ah, that was dumb. Should have copied this, pasted it in here, then gotten rid of the x and y. You can have the x and y if you want, but they're not necessary. So here we go. We got the values that we pass to the function. Now the square braces are interesting. This is something you don't have in normal functions. These are the captured variables, because a lambda function takes place within the scope of another normal function. You can capture variables that were within that scope. So we can capture x min, x max, y min, y max. And we'll be able to use these variables within our lambda function now. Now the return value is defined with the little arrow here, and that's just outcode. And now we put our function body in. And we do that by creepypasta. And now because we're capturing x, min, etc., we don't need to define it within the function, the lambda function body. I'll do that. There we go. And there we go, we have our lambda function defined. And it doesn't like, here we go. Last thing, and this is easy to forget, even though it's a function definition, this whole thing is a statement. It's saying create this lambda function and assign it to our function object. So because it's a statement, needs a semicolon. And we should be all done. So now I can delete this. And I'm coming for you next. But first we'll build. Succeeded. And yeah, we got our shit. It's still working. We did not fuck our shit up. But we made our code sexier. And I still don't get why I get this fucking exit sometimes, but not other times. It's fucking messing me up. Actually, I only get it really when I'm recording the video, which is weird. So it's something with my recording software, but whatever. So we have a lambda function now. And here it is. Capture your function parameters, your outcode, or your return value, which is an outcode. Now, let's also do this. Ints are fine, but let's try and do it with type define int outcode. Yeah. Let's also put this within the function. Now how we're going to do that is we're going to make it an enumeration. So type define, I don't know if we need type define. Let's just type enumeration out code let's copy this bullshit. Delete that, delete that. We don't need constant or int. We'll let the compiler decide the correct size, but we need to have these specific values. And you're allowed to specify specific values for enumerations just by putting an equal sign there. So there we have our enumeration outcode. We declare it here before our lambda. And now there's one problem. And that problem is you're allowed to do operations on enumerations like or and. So this works fine. But when you do that, you turn that enumeration into an integer. It gets transformed into an integer. And you can't assign an integer to an enumeration unless you unless you cast it, explicitly cast it. So what we got to do is we got to go do code is equal to code, or there it is, left. Still doesn't work because we're still assigning an int to an enumeration, so we got to go int. There we go, and that works. I said it works. Well, it will work once the IntelliSense catches up. So it's left, right, bottom, top. Copy. Left, right, bottom. Oh, I did it wrong. Okay, dumb outcode. We got to, obviously we want to cast it to outcode, not to int. It already is an int. So, left, right, bottom, top. So there's just a little bit of shenanigans we got to do to make enumerations work with our bitwise operators here. But you do it, and now we can get rid of this bullshit, and hopefully we'll build properly, and we do. And you see, my friends, now we have all of the draw clipline stuff contained within the function. It's got none of its bits hanging out, flopping in the wind. That, my friends, is sexy. Shit flopping in the wind, not sexy. Alright. And no change, of course, in the behavior of the program. We didn't change any of the actual algorithm. We just cleaned the code up a little bit. Lovely. And we get our error again, of course. Yeah. Alright, time for water. Alright, so, yeah, good stuff. Good stuff. That's clipping. Now, here's the thing. I like this a lot, but I like my spinning dongs in space. Teabagging down here. Yeah, dip it low, bring it up slow. But I feel a little bit inadequate here. I think it's time for some male enhancement. We're gonna have to scale our model here. I want to introduce the scaling transformation to you guys. Now, scaling is very simple. Let's delete this. Get a new one. If you've got caps lock. If you've got a let's say this is the center in your model space. This is 0, 0. And you've got a model like this. It's a triangle. And you want to make it bigger. All you got to do is multiply each of these vectors by a scalar. So if you multiply this one by 2, it's going to go here. If you multiply this one, the x and the y by 2, it's going to go here. Multiply the x and the y by 2, it's going to go here. And you're going to get your scaled object. So to scale a vector, you multiply it by a scalar. That seems like it should be pretty easy to remember. That's why they call it a scalar. Hint, hint. So we want to multiply. Where is it? Polyclosed. Here, and when we do our transformation here, we want to multiply this by a scalar, and then do the translation. Translation has to be done last. It doesn't matter if you multiply and then rotate, or rotate and multiply. As I established in the last lesson, those operations, the order doesn't matter. But the order of translation does matter. If you translate before you do another transformation, it will change the result. So we want to multiply by a scalar in here. But what scalar shall we multiply by with? Now here's what I want to do. I want to make the controls such that when we rotate the scroll wheel on our mouse, we can scale the ding dong. The problem is that the current mouse system doesn't have anything for mouse wheel. And what's furthermore, the bigger problem here is that the current mouse system is based on a polling system. Remember a keyboard, if you remember from the platformers, we added functions here for event queuing. So you have events here, a queue for key events and a queue for character events. And then you can check the queued buffer for events and handle them as single events. However, in our mouse, we can only check the current state of a button. Is the button down? Is the button up? The problem is that the scroll wheel isn't a button. It doesn't go down and up. It just generates discrete events of scrolled up or scrolled down. So we need an event-based system if we're going to use the scroll wheel. And that means we have to renovate our mouse server and client much in the same way as we did with the keyboard. Now, in the last try for this video, I actually did that on screen. It took a while, and it was kind of boring because it was exactly what we did for the keyboard server. So I'm going to be a nice chili. I'm going to be a super cool guy. And I'm going to give you guys the code for the event-based mouse. So you can download this on the forums, on the download page. It's on a sticky at the top. If you don't know that yet, then what the fuck? So we got to close our solution. Open this up here. Open up our zip. Drag this into Engine. Copy and replace. Copy and replace. And reopen our project. Drink a little water and do a little dance. And let's take a look at mouse. So now we have a new class. It's the mouse event class. L press, L release, R press, R release, wheel up, wheel down, move, and invalid. And a couple of functions for that. And we have our mouse client, which gives a new function read mouse and mouse empty. Burp. We still have all our old polling events if we want to use them, but now we also have polling functions, and now we have event functions. And we have our mouse server, which has new functions for wheel up and wheel down. And also I changed the other event functions so that they take X and Y. So now every single event will also carry the X and Y parameters, not just move, but all of them. And there's our queue, buffer size, everything is fine. Now we've just got to rearrange the rest of the solution to fit with the new mouse system. So we're going to build and find out where we are going to rebuild, find out where all our errors are. Where's my, I don't want warnings, I want errors, bitches. So mouse. So we had to change before. Mouse client had a constant reference to server and everything was constant, but now because server has a queue and the queue is going to be modified, the client is going to remove items from the queue, we can no longer have constant here. So we have to break up our constants. So here it's a constant. Get rid of that. We'll go toggle header and we'll get rid of constant from here as well. Let's build. Alright, so mouse server on released. Okay, here is the Here's where we have all of our messages for handling Windows events. So here's the mouse move message, and there's a whole bunch of crazy bullshit in here for handling whether the mouse is on the screen or off the screen, and if the button is being pressed down, what happens, as opposed to if the button is released. But that's not our problem. Our problem is that now on our mouse button press events, they need an X and a Y. So what we're going to do is we're just going to, first of all, put the X, no, that's dumb. Copy this. Paste that there. There. That'll fix that one. Except here, dumb, here, and here, we don't have X and Y. That was created up here. So what we have to do is we have to extract the X and the Y values from the L param, which is just a parameter that's passed when you get a Windows message, and put them in here. And that will work, except it won't work. Let me show you why. X is skipped by case label, Y is skipped by case label. So you can't create new variables within a case label. You've got to create them either outside of the switch function, or you have to create a new scope within the case label by adding this curly braces. So we're going to create a new scope inside the case label. Now that is going to fuck up our bullshit. But it can't be helped. By the way, you can select and then you just go Shift Tab to detabify. For those of you who don't already know that little shortcut, I use it a lot. So we're going to create a new scope in here. And that will let us create new X and Y variables. Now, I just want to make this match my other ones. So I'm going to go, interesting. This one puts the break after the thing. I'm going to put the break inside. Doesn't matter where you put it. Then I'm going to Shift Tab this so that it matches with the other ones. Because I have OCD. So there we go. That should allow us to build, unless I missed another thing. Okay, we built. And just for safety's sake, everything works fine, no problems. Good. Now we have to add our event, our message handler for the mouse wheel, because we haven't done that yet. So we need to know what the name of the message is for the mouse wheel. So we go Windows SDK mouse wheel message. Here we go. WM mouse wheel. So there's one message for the mouse wheel, and there's not like a separate message for up and down. So that means that we inside one of the parameters here is going to be the up and the down. So what do we got here? W param, the high order word, so the top 16 bits, indicates the distance the wheel is rotated, expressed in multiples or divisions of wheel delta, which is 120. That is dumb. So basically, if you click once up, the value should be 120, and if you click once down, the value will be negative 120. Positive value indicates that the wheel was rotated forward, away from the user. Negative is backward. Okay, so we have a little function here, get wheel delta W param. We're going to be needing this one. But first of all, let's copy this. and case mouse wheel. And we are gonna, yeah, I know, you want to indent your shit. So x and y is equal to that. Now here's the deal. What we're gonna do is we're gonna go if. We're not gonna care about the value of delta. There's some bullshit in here about special mice that have, what is it? Delta was set to 120 to allow Microsoft or other vendors to build finer resolution wheels, freely rotating wheels and no notches, send more messages per rotation, but with a smaller value in each message. So this is dumb. And then you have to add the incoming delta values until wheel delta is reached. But we are going to ignore mice that have finer wheel resolution. So if those mice exist, if you have one of those mice, you're going to have to figure something out. Because I don't have one of those mice, and I'm not going to fucking try to figure shit out on conjecture here. So we're going to assume that everyone using this program has a normal wheel scrolling thing. And so every event is going to be equal to one wheel delta. So we're not going to be interested in the value of wheel delta, just its sign. So what we're going to do is we're going to take this get wheel delta. And we're going to go if get wheel delta w param is greater than 0. Then we're going to mserve dot on wheel up xy. Else, if for some reason we get a wheel delta of exactly 0, we're not going to do anything because I don't even know what that means. Then mserve dot on wheel down xy. Lovely. And that's it. And then we just break. And that should be all we need. Let's build. Good. Now we have to incorporate this bullshit into our program. So first things first. Poly closed. We need to modify our draw function to take a scaling factor. Then we're going to multiply by scale before we translate. And that's fine there. Now we have to go into game. We'll add a scaling factor here. We'll set it to start off to be 1, no scaling. And we got to go to game.cpp. And we've got to handle mouse events in here. So what we're going to do is we're going to go switch mouse dot read mouse dot get type. And that will return the enumeration type of the mouse event. Then we're going to go case. What do we got here? Mouse event wheel up. I fucked that up a little bit. There we go. So case wheel up. In the case of wheel up, we want to go scale times and equals 1.13, I guess. I don't know. Just some random scaling up factor. Break. Case mouse event wheel down, scale, divide, and equals by 1.13. Break. There we go. And that is how we handle our mouse events. Now in here, we've got to add the scaling factor, so we go scale. Wait, scale comes after angle. Don't get those mixed up. It'll fuck up your shit. There we go. And that, my friends, should be all she wrote. And now we have our rotating dingle-dong. And if I... Whoa! Okay. Alright, that is... Let me just tell you, for the unlucky lady, that would be painful. Just saying. So I fucked it up a little bit. Let's see where Chili fucked it up. It's probably something simple. I hope. Let's go to game. Let's go to poly closed. Okay, what do we got here? So I am only scaling one of the endpoints of every of the lines, and the other endpoint is staying the same. There are two vectors in a line, and I'm only scaling one of them. So let's scale the other one. Just for fun. Just for shits and giggles, you know. Because we're funny like that. Alright, let's try this out again. That was interesting, but here we go. Oh, look at that. Look at that. Oh, it's just so big and dingle-dongly. So yeah, that's scaling. Scaling was very simple. But now we also have our mouse updated. We can use the scroll wheel, which might come in handy, or it might not. But it was fun nonetheless, wasn't it? Delving into the Windows API, the horrible piece of shit it is. And more importantly, we are able to clip our lines. We can clip our shit now. And that will enable us to work on drawing a map on the screen. But before we do the map, we're gonna incorporate a viewport camera system so we can scroll. But before we do the viewport camera, we're doing next episode matrices. Yes, what is the matrix? We will answer the age-long question. We will take the blue pill. I forget which one it was. Red pill. We'll take one of those pills. We'll take all the pills. I found pills. So, yeah, next episode, matrices. Get ready for more horrible, horrible tablet drawings and Chili talking math at you for about an hour. So, look forward to that. And see you guys later. Oh yeah, and don't forget, if you liked the episode, push the like button. It makes me happy. Every time I upload a video, I'm like the next day I hitting that refresh button. Did someone push the like? And no one ever pushed it. Makes me sad. So, see you later. Talk to me on the forums if you got questions or you just want to chill out. Peace.